Okay, so today I'm gonna discuss examples of how to construct discrete probability distributions. Okay, so looking at the PowerPoint, so let's use the first example. So an industrial psychologist administered a personality inventory test for passive aggressive traits to 150 employees. So individuals were given a score from 1 to 5, where 1 was extremely passive and 5 to be extremely aggressive. So a score of 3 indicated neither trait. So construct a probability distribution for the random variable x. Okay, then graph the distribution using the histogram. So what represented on the right is the table. So here, our random variable x is actually the scores and the frequency that gives you a total of 150 if you add them all up. Okay, so if you want to construct a probability distribution, the scores on your left, this one represents your x. And then your probability would be the empirical probability for each. So it's going to be 24 out of 50, 33 out of 24 out of 150, 33 out of 150, 42 out of 150, 30 out of 150, and 21 out of 150. So that leads us to this one. Okay. So notice gets are the probabilities, and then you put them all on a table like this. Okay. Notice that this follows the rules because each of the value of x has a probability between 0 and 1, and the sum of each of the probabilities when added up equals 1. Okay, let's have another. So notice, as you can see from there, continuing, it tells you that it's a valid discrete probability distribution. Okay, so this is an example of a histogram for that. Okay, so notice the x-axis represents the score or the x values or the random variable, and y would be the probability. Okay, so this one kind of looks like closely symmetric. Okay, so have another example. Okay, so let the random variable x represents the number of people waiting in line at subway. So suppose a subway near our school and it happens only to take the values 2, 3, or 5 with probabilities 2 over 10, 3 over 10, and 5 over 10. So what we're going to do is to construct the probability distribution table and the discrete probability density function. Okay. So notice this represents x values only represents three numbers, 2, 3, or 5. And then each has a probability 2 over 10, 3 over 10, and 5 over 10. That represents the table right there. Okay. Now the discrete probability density function, it's the function that represents this table. Okay. Now if you notice that. Okay. So in this case, okay, the function that would represent this would be p of x equals x over 10. But this one applies only to values of x, which is 2, 3, or 5. Because when x is 2, it's 2 over 10. When x is 3, 3 over 10. When x is 5, it's 5 over 10. Okay. Again, this is valid because each of the probabilities is between 0 and 1. And the total number, or the total sum of the probabilities is 10 over 10, which is actually equal to 1. Okay. Let's have another example. Okay. The student randomly guesses at two questions of a true or false quiz. Let the random variable x be the number of correct guesses. Okay. So find the probability distribution of x. Okay. So the number of correct guesses at two questions could be that they don't get the correct guesses. So 0 correct guesses. Could be 1 correct guess or 2 correct guesses. So 0, 1, and 2 are your x. Okay. So notice, okay, and then the probability and the sample space corresponding to that would be W, W, WC, CW, and C, and C. Okay, where W is the wrong guess and C is the correct guess. Thus, if you try to notice, this will result to your probability distribution. A 0 correct guess, which means both questions were what? Wrong. And that gives you only 1 out of the 4 choices. One correct guess, that's going to be WC and CW. That's going to be 2 out of 4, which is 1/2. And then when both guesses are correct, you get 1 out of 4. Okay? Now let's go to the next one. This one is pretty much straightforward. So in a college statistics class of 20 students, one student is 16 years old, 4 are 18, 9 are 19, 3 are 20, 2 are 21, and 1 is 30. So since the class has a total number of 20 students, that's going to be your probability down right here. Okay? Okay? So if you notice that, the random variable is the age of any student. So the ages ranges from 16 to 30. Okay? and then basically put in the empirical counts. Okay? Next one. This one you gotta listen carefully. Okay? So a fair six-sided die has the following: a number 1 on one of the faces, a number 2 on two of its faces, and then 3 on the remaining faces. Okay? The die is thrown twice, and let the random variable x be the total score thrown. So construct the probability distribution of x. Okay, let's discuss this further. So this one only contains 1, 2, and 3. Okay, so which means 4, 5, and 6 are not included. So we'll not include them in the table. Okay, so since the dice has 6 faces, so which means you have 1 ones, 2 twos, and 3 threes. Okay, so again, the random variable is the sum of the two numbers when rolled. So roll the first dice, get the number. Roll the second dice. Okay, second time. So roll the second twice, then get the number, and then we add them. Now this results to a dice configuration. That's what we do normally when we have problems on the dice. So we get now the following. Okay, notice on the one on top: 1 ones, 2 twos, and 3 threes. Second, and then 1 ones, 2 twos, and 3 threes. So the numbers that you see right here is the sum when you add those two numbers. So the possible sum starts from 2 and ends up at 6. Notice there are 36 possibilities. So that's going to be your denominator. Okay. So basically, all you got to do is simply count how many 2s, how many 3s, 4s, 5s, and 6 out of 36 for each. Okay. And then that represents your what? Probability distribution. Okay. And the last example, this one: a team of 3 is to be chosen from boys and girls, from 3 boys and 4 girls. So x here is the random variable pertaining to the number of girls in the team. Construct the probability distribution of x. So since it is a team of 3, okay, so the number of girls could be no girls, 1 girls, 2 girls, all of them are girls. So your x stands from 0 to 3, not 4. Even though there are 4 girls, the number of people in the team has to be only what? 3. Okay? So this one uses combinations because you're picking 3 from a total of what? 7. 3 boys and 4 girls. Okay? So the general count is actually, the number of possibilities is 35. Okay? So that's going to be in the denominator. So you're going to be choosing 3 people. Okay? But your x starts from the number of girls. Could be 0 girls, 1 girls, 2 girls, or 3 girls. So from the 0 girl, which means from the 4 girls, you're going to pick nothing. And from the 3 boys, you're going to pick them all. Okay? So if I use the combination of this, that's going to be 1. So when x equals 1, from the 4 that are girls, I'll pick 1. From the 3 boys, I'll pick 2. If I use this combination, I get 12. From x equals to 2, there are 4 girls, I'll pick 2, and from 3 boys, I'll pick 1. If I multiply this, that gives me 18. Okay, and the last one, that gives me what? 4. So obviously, if I add those numbers, that totals what? 35, which means this would now be your table. Okay, so when x is 0, it's 1 out of 35, 1, 12 out of 35, 2, 18 over 35, and 3 would be 4 over 35. Okay? Do you have any questions?